So as we consider coterminal angles are just angles that simply end in the same place. So as I look at this angle right here, this angle is going around 5 pi over 4 and it's stopping. This is my terminal side at 5 pi over 4. But I can certainly keep going around, right? I can take that 5 pi over 4, I can go around again and stop again at 5 pi over 4. So if I go around this distance right here, see how I'm starting at 0 and I'm going around and I'm stopping? So that distance right there is 2 pi. So this is simply 2 pi plus 5 pi over 4. So if I put that over 1 and get a common denominator of 4, right, if I multiply by 4 over 4, I'm going to get 8 pi over 4 plus 5 pi over 4. And that is 13 pi over 4. So that means 5 pi over 4 and 13 pi over 4 are simply coterminal. They end at the same place. And I can do that as many times as I want. I can keep going around this circle as many times as I want. And every single rotation is 2 pi. So 2 pi, another 2 pi, which is 4 pi, another 2 pi, which is 6 pi, and I can keep going, and I can do that indefinitely. I can also go in the negative direction, right? So I can go, but that's still going, as long as I'm going around the circle, that's still 2 pi. So if I were to ask you to label, or to tell me how long this blue line is, or how big of an angle this is, can you see that if I start here at the middle, I go around, that's 2 pi. If I completely went around again, that would be 4 pi. So going all the way around twice is 4 pi, but I didn't quite go that far. So what I really want to do is I want to do 4 pi minus pi over 3. So we just have to do a little bit of algebra. So that's going to be 4 pi minus pi over 3. I got to get a common denominator, so by 3 over 3. So I get 12 pi over 3 minus pi over 3 is 11 pi over 3. So this length around the circle is, to this terminal side, then would be 11 pi over 3. So if we were given two angles and I wanted to know whether or not they are coterminal in fact, well, coterminal means that there is some multiple of 2 pi being added to the smaller one in order to get to the larger one. So what I can do, there's several ways of doing this. There's a shortcut to doing it on the calculator. If you can figure that out, that's great. But I really just want to teach the straightforward way to doing it. So this is going to be pi over 9 plus, so what I'm going to do is I'm going to add 2 pi. So that is really going to be pi over 9 plus 18 pi over 9. So that's 19 pi over 9. Well, that's still not 37 pi over 9, but what I can do is I can see if 19 pi over 9, let me see if I can, 19 pi over 9. So what I'm going to do is I'm going to do 19 pi over 9. I'm going to add another 2 pi, right? So add another 2 pi, or add 19 pi over 9 plus another 18 pi over 9, just coming up with a common denominator. And in fact, I do get 37 pi over 9. So by adding 2 pi twice, or 4 pi, I added 2 pi twice up here to this smaller angle, and I did in fact get that other one. So let's do one more of these. I want to simply find the angle measure of this blue line right here. So I want to find this angle measure. So, and I should have put an arrow in here. So obviously I know I'm going to have a negative angle. Hopefully you guys also know that if we're going backwards, we're talking about negative angle. So there are several ways to do this, one with addition, one with subtraction. I like to add. So the first thing, I'm just going to piecemeal this guy together. So I know that this from here to here is just a measure of pi, right? So halfway around a circle is pi. So I can simply do pi, and then I also am given that from here to here is 3 pi over 4. So I can simply add that. So pi plus 3 pi over 4. So we come up with a common denominator. So I'm going to get 4 pi over 4 plus 3 pi over 4 equals 7 pi over 4. But remember, because I'm going backwards, I want to just make that a negative value. So this measure over here is negative 7 pi over 4. So the last thing I wanted to talk about were reference angles. So if I asked you what the reference angle for 5 pi over 3 is, well, the first thing I'm going to do is I'm going to draw 5 pi over 3, and we know from our unit circle, we know 5 pi over 3 is in our fourth quadrant. So 5 pi over 3 goes this far around. But the reference angle that I'm talking about always is going to go to that x-axis. So you draw your terminal side, and then wherever you are, you go direct, you make a right angle with the x-axis. So if you're in the fourth quadrant, you're going to go up to the x-axis. And then what I want to do is I want to actually find this theta. I want to find that angle. So can you see that that is going to be 2 pi minus 5 pi over 3? So if I come up with a common denominator, I'm going to get 6 pi over 3 minus 5 pi over 3, which is simply pi over 3. So this reference angle, the reference angle for 5 pi over 3 is simply pi over 3. Does that make sense? All right, so now let's look at a second example. I want to know where the reference angle for 495 is. Well, 495 is going around the circle more than once. So let me actually get rid of this stuff here. Oops. So 495. So I'm going to subtract 360. That's the first thing I'm going to do. So if I subtract 360 from that, I get 135. So really what I want to know is because they're coterminal with each other, right? 135 degrees and 495 degrees are coterminal. So I just want to know where 135 degrees is. So that's going to be in my second quadrant. That's actually on the unit circle. So this is 135 degrees, but my reference angle always goes to the x-axis. So I drop a line, a right angle, to the x-axis. And I've said before, if you're down here in the third or fourth quadrants, you have to go up. So you have to go up to the x-axis. If you're in the first quadrant or the second quadrant, then you go down to the x-axis. So this is in fact my reference angle, and this is the theta that I'm looking for. So if this is 135 degrees, can you see that that's going to be 180 minus 135? So this angle right here, this theta, is 45 degrees. So my reference angle for a 495 degrees is 45 degrees. It's what completes that angle to the x-axis is kind of how I think of it.